it looks like we're at time, so I'll give folks, some moments to trickle in while I kind of start off with a little introduction about myself and Acelab. We're helping to host this event with Candace from Total Door Systems. So I'll give you a quick rundown of what Acelab does and who I am, and then we can get started with Candace's presentation. I'll give you a quick background about myself. I studied architecture at Tulane, and that was kind of how I got into this world. Practiced in New York for a few years after graduation at firms like OMA and a few other small residential firms along the Northeast. After that, I moved to Denver, where I live now, and joined on to Acelab as an architectural product specialist. So at Acelab, I work with architects and builders who want to use our platform and our database of over 19,000 building products to be able to help in the research process in their product specification workflows. So our technology is data-driven, it's non-sponsored, it's also free to use. This is a quick snapshot of some of our core team. We're built by architects for architects, so we are kind of here building the tools that we wanted to see ourselves in practice. And something that we're really excited about that we are starting recently is offering this new feature called research reports. So these are personalized reports for your projects, helping you to compare 3 products in depth, all in one easy to read formatted document. So we're really excited to start offering these to architects. And I will take you over to our site, give you a quick demo of how you can upload a project. That's the easiest way to get started collaborating with Acelab, get started requesting these research reports. So if you make an account, you can go ahead and sign in. Head over to my projects at the top right. This is your personal project dashboard. You can click a new project, and we only ask 4 questions to get started, so it's pretty easy to onboard as many projects as you'd like. Really, what's most important here is this expected start date for product sourcing. So that's just to let us know when you are looking to start researching products. Someone from our team will reach out to you at that time and find out what we can do to help you get started using our platform and get the information that you need. So you can go ahead and do that, create your project, and then you're done. Someone from Acelab will reach out to you at that time that you set. You can also come back to your projects page and add additional info, upload supporting documents, that kind of thing whenever you'd like. Okay, so if you are interested in connecting with someone from Acelab's team to get a free 15-minute quick demo of our platform, learn how you can use Acelab in your workflow, I'm going to put up a poll in a few moments, and you can just answer yes to that poll, and someone from our team will reach out to schedule a demo with you. So we'll leave this up for a few moments, and we'll also probably let this go at the end for anybody who missed it. But yeah, go ahead and answer this poll if you'd like to receive a demo, and we're happy to walk you through our process more. I'll just leave that up for a few minutes. But with that, I'm done, and I can hand it over to Candace to get started with our presentation for today about fire and smoke rated systems.
There we go. Thank you. Thank you so much for that introduction, and thanks for setting this up today. Today we have integrated fire and smoke door systems specifying your own safety net. My name is Candace. I'm with Total Door. I've been with Total Door about 3 years now. I'm located in Michigan, Waterford, Michigan. So I bring up my hand map. We're about right here, about an hour from Detroit. So if you need anything, you can reach us at designsupport@totaldoor.com. I am going to turn off my video for this portion because I like to stand up and walk around when I present, and it's distracting. So we will have time at the end for question and answer. So here we go. You will receive your credits as well. That's eligible for 1 learning unit / health, safety, welfare hours, as well as certifications if you would like those.
Oh, one quick thing to add to this. The place to give us your AIA number will be in the post-event survey. So that'll come up at the end of today's event. You'll also get a link to it in the post-event email. So stay tuned for that.
Okay. Beautiful. Thank you. Yes. So make sure you fill out that survey so that we can get you your credits, especially at the end of the year. So of course, we've developed our learning objectives. Those are ensuring that we know the code that surrounds smoke and fire door systems, understanding the importance of these systems, learning about their applications, and then understanding the benefits. So The overall goal of the International Building Code is the protection of people, buildings, and that continuous product development. And so page 9 of the IBC specifically states that these codes are actually looked at on a 3-year cycle, hence them coming out, 2009, 2012, 15, 18, 21. And this allows us to look at new construction methods, look at new technologies, and we are incorporating those into the code. But then, without taking away any opportunities for new materials or new products, we're not having preferential treatment towards any particular types of methods of construction. And so, essentially, when we're covering integrated door systems today, the goal is going to be to provide solutions to safety without those unnecessary increased barriers. So we've got this presentation for you today, but it is a national presentation. I'm assuming most of you are from different areas on this today. But if you have a specific question to where anything I talk through today is located, please feel free to reach out. I know that typically it's going to be in a similar chapter or similar area, but it might be off by 0.1, 0.2. And so we can absolutely help you find those specific requirements. So a little bit on the history of the International Building Code. The famous saying is, of course, those who don't know history are doomed to repeat it. And so they designate a specific book to what changes are made and why. And so it's called Significant Changes to the International Building Code. This is the 2018 edition I have here. But it is 346 pages long. And so all of these changes and these modifications are constructed for risk management based on past events. And so these past events are why we have things like fire-rated walls and fire-rated doors, floors, cross-corridor protection. And so these 346 pages, they're going to be full of additions, deletions, clarifications, and modifications. Here I have an example for you. It's on page 182, and it says basically, because so many fire deaths are occurring because people are asleep at the time of a fire, they're requiring sleeping rooms below the 4th story have windows or doors to be used for emergency escape or rescue. Why do I share that with you? Well, the point is just that as our information and our knowledge and the statistics that we find is evolving about fires and about smoke, the code is evolving with it. And we're adapting to that necessary change. So let's look at some trends. The following information that you're seeing on the screen here, this is from the U.S. Fire Administration and the National Fire Protection Association. In the United States, there were 1,291,500 fires in 2019 alone. 3,704 deaths, 16,600 injuries, and the cost of that was $14.8 billion. Now, this is really interesting to me, but the NFPA says that occupants have less than 3 minutes to escape a fire. The NFPA also says that on average, it takes the fire department 4 to 4.5 minutes to arrive on scene. So the math does not add up well for the building occupants. And so the big question that we're going to try to help answer today is how can we do our part in the protection of people and property? So now let's go through a case study. This is a case study of an apartment fire at the Twin Parks Northeast apartment complex in Bronx, New York. This is just earlier this year. So this was in January of 2022. 17 people died in this apartment complex fire. The fire actually started inside one of the apartments. It was due to a portable heater that had sparked and caught fire. And the fire commissioner singled out malfunctioning self-closing doors as a key reason smoke from the flames quickly engulfed much of the 19-story tower. Now, what's even worse is that inspectors from the city's Department of Housing Preservation and Development, they cited the tower 6 times between 2013 and 2019 for failing to keep all of the building's self-closing doors in working order. So 4 years prior to this devastation, the Prospect Avenue fires took the lives of 13 people. And what happened was an open door fanned the flames in a blaze that consumed that building. And so if any of you are living in New York or from New York today, all of this data may hit a bit closer to home. But in addition to that, 58 buildings in Queens had 100 open violations related to self-closing doors. A building in Brooklyn has 21 open violations. A Bronx building had 20 violations. And overall, as of January 11th, 2022, there were 18,305 open violations in 10,610 buildings. That's scary. So, what are fire doors and why do we talk about them? Well, of course, the previous couple of slides are why we talk about it. Because fire and smoke doors, they must perform reliably and correctly. And so really they have one job, and that is to save lives. And so to do that, they must be maintained in a constant state of preparedness. And so fire and smoke rated doors are for compartmentalization. Fire rated doors are doors to resist heat, fire, smoke, and they're going to be tested by those third-party agencies and just labeled to show that they meet certain performance requirements for whatever's required for that opening. And so they need to be able to essentially contain that smoke, that heat, that fire from the building occupants long enough to have them escape that burning building. And so rated doors are evaluated for their fire performance, and it's going to be in accordance with UL10A, UL10B, or UL10C. And so they're going to have on their label the rating, A, B, C, 20-minute label, and the door is typically going to be rated for 3/4 of the surrounding wall. All right, so what is an integrated door assembly? Well, an integrated door assembly is going to combine the door, hardware, accessories, and sometimes the frame as a completely tested assembly. And so essentially, the hardware doesn't need to be labeled separately because the components of the system are going to be all tested together under a single testing label. So like in a conventional door or doors that wouldn't be considered integrated, you would essentially need to have labels on each piece of hardware because it's not been all tested together. So the first integrated door assembly went on the market in 1975. And they would be ideal for exits, cross corridors, stairwells, elevator lobbies, elevator shafts. So an integrated door system is going to install 4 times faster than a conventional door. So you could get a door like the one on the left where you'd put it together on site, maybe risk losing pieces or parts. And you may even find that an installation warehouse is necessary for installation. There's just these unknown conditions in the field. Maybe you don't have the right tools. Maybe the lighting is inconsistent, whatever it is. Or you could get a door like the one on the right that's complete and ready to go into the opening. And that means that fewer trades are going to be involved, fewer manufacturers involved, improving your quality, improving your efficiency. And so that single source responsibility will give you reliability. So the number of components in an integrated door system compared to a conventional door is 22%. And so 61 parts sounds a lot better than 278. Now, both of those numbers are high. Why? I am counting down to every single screw. So I'll give you an example. Kick plates. On an integrated door system, a kick plate is actually going to just wrap around the edges of the stile, hence 1. Now, on a standard conventional door, a kick plate is going to be actually riveted into this surface of the door, hence 1 piece for it and 12 rivets. So essentially, conventional doors are going to include pieces and parts that are really just not necessary to the system. And so you're paying for more than what you need and then increasing the potential need for maintenance or something to go wrong. But eliminating those extra parts is going to bring you a cost savings and increase that performance. And so in this quick video here, I just want you to watch as the bulky hardware is going to be removed. So the astragals, the coordinators, the surface mounted closers, the surface mounted kick plates, all of that is going to be removed, and then you'll see a more clean, streamlined look. So don't pay for a fire door that comes with extra pieces and components but doesn't have all the necessary certifications. So what I'm going to drive today is that complete code compliance. So this is right before our poll question, but just something in general. So integrated door systems are going to be tested to over 1 million cycles. But a lot of the components that would come on like a conventional door, they're only going to be tested to maybe about 100,000 cycles. So now we've got our first poll question. Our question is, what piece of hardware do you typically find fails first on a conventional door?
All right, we've got some answers coming in. Give folks a few more moments, but so far it looks like we've got quite a lot of people responding closer. And yeah, then about tied for astragals, vertical rod, and coordinator, but majority are saying closer.
Yeah, that's pretty typical, I would say, to what a lot of the other groups were responding. So yeah, that makes a lot of sense. The closer can cause a lot of issues. Those extra pieces and components like astragals, coordinators, they're only tested to 1 million cycle or 100,000 cycles. So yeah, that could cause some issues. And I am curious if anybody did choose other, I'll have to follow up with you later because that is always an interesting one. I like to see what people have to say. So that's great. Thank you for your responses. So now I want to look at an example of avoided costs. I can really talk about advantages all day, but what does it mean if you don't use one? So we're going to look at mean time to failure here. And how is that calculated? Okay, so this is typical for like usually computers or software. And they calculate mean time to failure as when 50% are still working and 50% are not working. So for example here, we're looking at ANSI, A-N-S-I, grade 1 panic devices. But we changed mean time to failure to be when 20% are not working and 80% are still working. Why did we do that? Well, because who wants to buy a product that's going to fail 50% of the time once it reaches its, expected lifetime? So we changed that a little bit. So we found out that the mean time to failure for an exit device is about 7.5 years. So if you look at the new cost of that device, it'd be about $750 plus labor, $375 for a total of $1,125. And so you're looking at an almost guaranteed extra over $1,000 spent on a door in a few years that really could have been avoided with an integrated door system. Now, if you look at the initial savings, you would have reduced labor, reduced material, and so you're looking at an initial total savings of $1,900, or again, at least the avoidance of paying part of that later. So doors and hardware are like 1, maybe 2% of the projected cost of the entire project, but they're also 20% of the entire maintenance costs. So we're trying to avoid that. Now, integrated door systems are completely compliant. So let's talk about some different compliance codes. UBC 7-2, that's your uniform building code. It's one of the first codes, and it goes through positive pressure testing, which brings me to UL 10C. That's your positive pressure test. UL 1784, that's your air leakage test. We'll talk about that on the next couple of slides. CAN ULCS 104, that's your Canadian standard. And NFPA 252 outlines the methods of fire tests of door assemblies. So what is UL 1784? Well, UL 1784 is the standard for air leakage tests. And so this is from 716.2.2.1.1, and it says that the air leakage rate should not exceed 3 cubic feet per minute per square foot of door opening at 0.1 inch of water for both the ambient temperature and elevated temperature tests. So when I go into it on the next slide, really when we bring up this code, we're looking at elevator lobbies and elevator shaft applications. And those are required to be tested to UL 1784 without an artificial bottom seal. So testing and evaluation results are something like what you would see on the right side of the screen, also indicating without that bottom seal, artificial bottom seal. Okay, so essentially UL 1784 is physically testing for smoke, and it's measuring specifically how much smoke travels through the jambs in the header. So what would happen is in the past, fire labs would essentially only be testing 3 sides of a 4-sided door opening. And so they would test how much smoke was traveling through the header and the jambs. And then at the bottom of the door, where there's typically that 3/4 inch undercut, they would place an artificial bottom seal there. So what was that artificial bottom seal, you may ask? It was a piece of tape on the bottom of these doors. And so I hope that you guys don't see tape on the bottom of these doors in the field. But the IBC recognizes, of course, that did not reflect reality. And it's one of the only places in the IBC where it actually tells you how you have to test and not just what you have to test to. And so fire labs now must test all 4 sides of the opening without an artificial bottom seal. Again, doors for elevator lobbies or doors in front of elevator shafts must meet this requirement. So let me give you a couple of examples to kind of explain a little further. Let's say I wanted to put a conventional door and hardware in there. I get a door body from this place and a lever from this place and a closer from this place, and I bring it together and I put it in front of that, and I'm saying, well, they're all tested separately, so it should work, right? No, that would not work, because according to UL 1784, the components of the door actually must all be tested together. Okay, so I bring in another door and I say all of these components have been tested together. It is an integrated system, but I'm just going to add an automatic door bottom later. That also would not work. You couldn't add like a conventional door sweep later. It would have had to have already been tested with the system prior to going into the opening. So really, you would need a completely integrated door system that's been 1, tested completely together, and 2, with a sweeper seal that has already been tested with it to go in front of those openings. Now, BHMA is the Builders Hardware Manufacturers Association, and they set the standards for performance that specifically impact builders' hardware. And so what's great about their website is you can actually go there, search any standard, and then all companies that are certified to that standard will be listed. But the standard 156.32 is for integrated door opening assemblies. Now, limited products are certified to 156.32 because it is extremely difficult to pass. So it takes months to pass this. There's twist, preload, force tests, impact tests, you name it. And they're very, very strenuous on the doors. And then after all of those tests, the doors must pass 1 million cycles. So to be considered a true integrated door system, you must test to this standard. Now, environmental product declarations, or ULEPDs, it documents how a product throughout its life cycle affects the environment. And so the goal is just that architects or those that are like buying the products, they can just make these informed decisions. So this is kind of replacing LEED, which I'm sure most of you are familiar with, but it can also be a supplement if you still need those LEED documents. But essentially, it's just going to break down all those materials that go into the door from the start to the finish. Now, your HPD is your health product declaration. And the goal of this is to provide material transparency, and it compares product contents to associated health information. So if a company has this, they'll be able to provide it. You just need to ask. And so I've got another question for you about sustainability documents. What percentage of products do you typically seek out sustainability documents on?
It looks like about half the people have answered, so I'll give it a few more moments before we share the results.
Sure.
Okay, interesting. Cool. Give everyone a few more seconds. All right, anyone who wants to put in their response last moment before I end the poll? Cool, okay. So end and share the results. There you go.
Great.
So majority in the 0 to 20%. And looks like a few people at that 81 to 100%, which is cool.
Yeah, that's definitely good to see. A couple people there in the 81 to 100%. Pretty mixed in the 21 to 40, 41 to 60 there. And then, yeah, definitely the majority in the 0 to 20%, which I'm not surprised about either because, you could get one project that requires nothing and you can get one project that requires everything you could possibly think of. So, yeah, that's really interesting to see. Typically, I see a little bit more in the 61 to 80 and a little more in the 41 to 60, but yeah, it's good to see when people are wanting those types of documents, definitely.
Cool. Awesome. All right, thanks everyone.
All right, so now we're going to look at red list items. Typically, I see this in California most often. But there are 816 items on the red list, so if your project has no red list items, then your building is going to be considered living building status. And this is just created to protect occupant health. So a couple of examples on the list are like lead, mercury. We're just trying to find alternatives to these listed items. So mercury is no longer in our light bulbs, for example. And so, of course, time is money. Collecting documents, hoping that it meets your expectations, waiting for responses, it all costs time and money. And so that single source should save you that. Now, integrated door assemblies are smoke and draft control doors. So what's smoke and draft control? Well, those doors must be tested in accordance with UL 1784 as a complete system. And that's where the air leakage rate comes in again. And we're really driving the importance of the S, that smoke label on these types of doors. It indicates that smoke rating. And so in section 716, it covers those labeled protective openings. That these door assemblies need to be labeled by an approved agencies and that these labels need to comply with NFPA 80 and permanently affixed. And so right on the example label you see on the screen, you can see who it's been tested by, the S, which is your smoke label, smoke and draft control, certified to UL 1784 without an artificial bottom seal. It's 90-minute. You have everything you need on there to make it really simple for when your code officials and your fire marshals are coming through and inspecting. And that protection at openings is really going to be all about assessing risk and protecting people. And so metrics and measurability are going to be used to forecast potential threats and their associated impacts. And this is really just all based on data. And so in reality, smoke accounts for 76% of deaths, damages, and injuries. So I've got an example for you. This is on a well-known insurance company's website, but this is for general liabilities. This is an example they have. It says, a manufacturer of power meat slicers is sued, alleging that the safety guard on the slicer failed to perform, resulting in partial amputation of a right thumb and finger. The manufacturer is found liable. General liability would respond to the $250,000 loss. Why do I share that with you? What does it have to do with doors? Well, if the loss of two fingers is up to $250,000 because that manufacturer failed to have a safety guard on there that was working properly, that was needed, then what would the cost of a life be? And so, what would a building that failed to provide safety according to the code at the elevator shaft cost? And what would it cost the people inside the building? There was the MGM Grand Fire in 1980 in Nevada. That took the lives of 85 people. What's the cost of that? And what's important about that statistic of 85 people, Of those 85, 79 of them died due to smoke inhalation and carbon monoxide, or dioxide, excuse me. But when we know the code, we know how to protect property and we know how to protect people. This is an example. It's the Penobscot building in Detroit, Michigan. This is early January 2020. And the fire started in the elevator shaft in the 5th floor as an electrical fire. And by the time the fire department could arrive on scene, which remember that's 4.5 minutes, the smoke rose above the 40th floor. So that means in 4 to 4.5 minutes, that smoke without protection rose over 35 floors. Now, luckily, no one got hurt in this case, but let's look at smoke damage cost. Well, the average smoke damage cost is over $7 per square foot based on our research. And the Penobscot building, you can see it's tall. It's 996,000 square feet, which makes the estimated cost of repairs over $7 million, which is more than what the owner bought the building for. Okay, so we've established why we need to know code and what to use to protect people and buildings. But now we can look at where to use these integrated systems. So what you see on the screen, these are just locations where fire and smoke rated swinging doors may be required. I won't read it out to you. I know you can read, but knowing the occupancy levels, the egress plans, the wall ratings, all of those things are going to help you to identify when integrated door systems are needed. Okay, so we've talked about fire door locations. We can talk about applications. Elevator lobbies are an application for fire and smoke rated doors. So doors that are creating elevator lobbies are required to be tested to UL 1784 without an artificial bottom seal. And that's that vertical protection focusing on that air infiltration. In the IBC section 3006.2 covers hoistway opening protection, and it's probably what most of us are most familiar with. As far as 3 stories or greater, you need that elevator lobby protection. Well, 3006.2.1 covers the need for protection in a rated corridor regardless of the number of floors. And it oftentimes gets superseded or overlooked because, you know, it's after and you probably think we've got everything we needed. But section 3006.2.1 supersedes any of the provisions or exemptions from 3006.2. So that means that if the elevator is on a rated corridor, regardless of the number of floors, that elevator needs protection. And so on the screen, you can see that there's 2 elevators. There's a pair of same swing doors. They're creating that lobby space for compartmentalization. So if those doors were tested to UL 1784 without an artificial bottom seal, then they would be compliant. Now, additional doors at the elevator shaft are just another way to provide that compartmentalization for elevators. And so the additional doors at the elevator shaft must be tested, again, in accordance with UL 1784 without an artificial bottom seal. What's great is, like, if you don't have the space to build an elevator lobby, this can be a great alternative. And the additional integrated door system can just mount around the outside of the elevator shaft and it'll close in the event of a fire to compartmentalize. Now, the only time that you couldn't do this would be like occupant evacuation elevator lobbies or fire service access elevator lobbies. Those actually do require a full lobby. So this elevator shaft on the screen would need protection. It's opening onto a rated corridor across from sleeping units. And so in order for them to like build a lobby, they'd have to build walls around the elevator, added cost. But a simple fix would just be to put a rated assembly right at the elevator shaft. And no lobby build out would be required, and the building would of course still be up to code. So this is actually a video of a virtual reality experience. So hopefully one day we get to cross paths and I have my VR headset with me so you can try this out. But with smoke protection at the elevator shaft, you're going to see that the door system is going to close, containing the smoke inside the elevator shaft. Now the door system is triggered by the smoke alarm and it will close and latch on its own. Now without that smoke protection, it will take just seconds to have very little visibility. And these are precious seconds, assuming that you already knew there was a fire, already heard the alarm, were ready to escape, we're already in the lobby. And so if you were mere seconds too late, without that smoke containment, you wouldn't be able to see at all. But with proper protection, you can see the exit signs and you can escape safely. So you may find smoke and fire doors in stairwells. Of course, stairwells are just like another essentially chimney in a building, just like your elevator shafts, and so they're going to need that protection. And your 909.20.3.2, that goes through the need for these doors to comply with section 716, and 716 is where it calls out your assembly door for that smoke and draft control. Now sections 403.5.4 and 405.7.2 are talking about interior exit stairways and where smoke-proof enclosures are required. So this is still in the code, but essentially in the past we saw a lot of doors that are protecting interior exit stairways and exit passageways that had temperature-rise cores. And again, it's still a requirement, but in the IBC 716.2.2.3, the exception is that it's not required in buildings equipped with an automatic sprinkler system. So with most buildings now having that, that's definitely kind of going away and diminishing the need for that. But again, that stairwell, it's just another vertical penetration spot in a building, just like your elevator, and it does need to be protected. So the purpose of cross-corridor doors is to compartmentalize areas of a building. Now, the very last thing we would want is to essentially route someone into another smoky area. And if there was really no way to get out of the building, there needs to be a way to compartmentalize the area that's burning from your safe space. And these cannot be just fire doors. Why is that? If they were, you may not burn, but you would inhale all the smoke. And 510.2 actually goes into that horizontal building separation allowance and the area, the building height, the occupancy classification. All of those things are going to come into play when determining where that horizontal separation with assemblies is going to be required. So the picture here, this is a cross-corridor double egress separation. They needed both directions of travel to be available, and that's why the doors are swinging in opposite directions. Now the doors are separating two occupancies in the building, and they're pocketed into the wall, designed to be held open out of the way most of the time. But without these smoke and draft control doors, if there was like smoke in one area, well, then the smoke would easily travel through the opening and into that safe area. So 1009.6.4, that's for separation. It says if someone cannot use a stairwell, then they need an area of refuge that must be designed to minimize the intrusion of smoke. Really, that smoke is that really big thing. So now I've got a question for you. After you've seen all of these applications, do you have a current or an old project that could have used an integrated door system? So what we're testing here is, are you recognizing something that you did already or could have done with this protection?
Looks like about half of you have responded, so I'll give a few more moments before we share our results. All right, any last minute entries? Going once. Cool. All right. So there we go,
Okay.
quite a few yeses.
Yeah, quite a few yeses, a few more than ones about tied with the no's there. But that's great to see. It's great to see that hopefully either you're confirming that you're doing something right, or you're seeing something new. So that's really great. And for those of you that said no, hopefully you can recognize it in the future. So that's really great to see.
All right, thank you, everyone.
Okay, so we've gone through applications now. Now we can go through those vertical markets. So with cross corridor doors and the protection of elevator shafts and stairwells, we can compartmentalize that smoke migration. Remember, smoke accounts for 76% of death, damages, and injuries. And a lot of healthcare facilities, they're going to need an up to clear 8-foot opening, and that can be achieved with pocketing and low profile hardware. So people are often like sleeping, maybe they're bedridden, maybe they are in a wheelchair in hospitals, and they may not be able to use a stairwell. And so they do need to be able to have areas of compartmentalization where they could section off areas of a building and protect many, many lives. Now, of course, high-rise buildings, they're going to be subject to a lot of fires. Typically, they're going to be multi-use, multiple vertical openings like your elevator shafts, like your stairwells. And so it's important to note too, though, less than 75 feet might need it, depending if it's a rated corridor. Remember, we talked about that earlier. But when people are sleeping, there's those extra provisions. But with those high-rise, you're going to have those really large vertical openings. Now, most school fires occur between 8 a.m. and 4 p.m., of course. That's when the students and staff are there, right? Well, often means of egress doors and stairwell doors are required in schools for protection. And so there is hardware that's made for these like high traffic, high abuse situations. You know how students are always running, they're kicking the doors open, they're karate chopping the doors open. And so if they're held open unless triggered by the smoke alarm, they will take less abuse. Now there will be people sleeping in apartments and in condos, and that means that the condo or the corridors are going to be rated, and they're going to need that elevator shaft and stairwell protection as well. Again, that's a 3006.2.1. Now, the NFPA, they actually have a list of deadliest apartment building fires. It dates back to 1978. But what I like to point out is that there's a fire on there from December of 2017, so almost 2018. And I'm sure the latest Bronx fire 2022 is probably going to make that list as well. And I bring this up because something that's dating back to 1978, we would hope wouldn't have these current events on this list. But really, code compliance is one, still being overlooked, but two, fires and smoke are still a threat. And without that proper protection, lives are at stake. Your government, your office buildings, those are going to need that stairwell protection. If it's a tall enough building, they're going to need that elevator protection. But the idea is to have compartmentalization of smoke, and that preparedness will save lives. Fires in hotels result annually in 9 deaths. And, well, 9 deaths really isn't a high number in comparison to the population, blah, 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 blah. It's too high. One death would be too high. And that's why we can create these spaces in a building that are safe from that smoke and that fire. So in the openings that we discussed previously, you may find single, double egress, same swing paired doors. There's many options for how the integrated door systems can go into these openings. And so there's no excuse not to be safe and compliant. So there's going to be varying degrees of swing that's available, custom sizes to fit these openings. So having that protection should be available. So now let's talk about vision lights or light kits. Well, 716.2 of the IBC, that's going to cover your fire resistance versus your fire protection guidelines for light kits. And typically when you get over 100 square inches, that's really where you're going to see that difference. But vision and light kits are going to be included in integrated door systems as like a part of the package. And so you really are receiving everything you need for a completely code compliant opening with the one system. Now I want to talk about ASME A17.1. ASME A17.1 is referring to additional doors in front of the elevator shaft, and it does have a provision about light kits. And so I want you to pretend that these doors on the screen are in front of an elevator shaft. And so ASME A17.1 says that there needs to be a vision kit in the first quarter opening for doors in front of elevator hoistways so that firefighters can visually see the elevator landing or lobby. So if the pretend elevator behind these doors were opening from the right side of the screen to the left side of the screen, that light kit would be in the first quarter opening. It would be in the perfect spot if they wanted to crowbar, the elevator shaft open just a quarter of the way, perfect. Now, if those pretend elevators were opening from left to right, that light kit would not be in the correct spot. They'd have to crowbar that door open 3/4 of the way, which would waste so much time, especially when time is imperative in these types of situations. And so it is interesting that this provision can be a bit tricky because I would think most intuitively we would put light kits typically on the latch side. That's where we usually would see them. But sometimes because of that first quarter opening provision, we might see a light kit actually on the hinge side, which is kind of interesting. So hardware on integrated door systems is going to allow for greater innovation. Now, since the hardware is designed and built with the door, it'll allow for that low profile hardware. And this maximizes that clear opening width and reduces possible damages. Less damages hopefully means less maintenance. But that low profile hardware, it's actually built into the door, and that's for maximum hideability. Now, the hardware has actually been designed to work with that door system to maximize performance. So you couldn't put the hardware on another door and vice versa. You couldn't put another piece of hardware on an integrated door. It actually wouldn't function the system. And so their hardware has been designed with no templating, no prep required, no coordinating with any frame prep or anything like that. Now there's many finish options for integrated door systems. So integrated door systems are tested as a complete system, and essentially we know the rating will hold up on the doors no matter the finish. So they're going to get what's called a certificate of compliance, stating that in their manufacturing facility, they can put any finish on their door because in the event of a fire, their door will stay up for the allotted time that it was tested to, and then the finish will just, come off, burn off, stay there, whatever it is. And so a multitude of finishes are going to be available. True wood veneer, architectural metals, architectural films or overlays, wall coverings, paint, primed. The only thing you can do in the field is paint the doors. Other than that, the manufacturer will have a certificate of compliance allowing them to put the finish on the door at the factory. Let's talk about specifications. Integrated door system specifications are specific to being doors being tested as a complete system. And so they need to be written in their own CSI standalone section, and they're going to be in 81713. So they'll be a bit different in scope, but you're going to have your system references, and those are going to be required in the submittals. And so in the submittals, it's going to require that you submit ULEPD, BHMA 156.32, certificate of compliance. We talked about those earlier, right? And then you can always ask for more. You could ask for your HPD, you could ask for lead documents, you could ask for UL 1784 information. But we want to make sure that we're specifying code compliant and certified doors and hardware. Now, again, all the components of the hardware need to be tested together. And so in the materials section, for example, gasketing is going to be automatically included. So you actually don't even need to specify that. And so instead of saying, lever from here and closer from here, it's just going to have a system hardware set at the bottom of the spec, and it's going to include everything: the door itself and the locking channels and the hinge, everything you need, and it's going to encompass all of that. Now, installation is going to be really important as well because it needs to conform to manufacturers' published requirements. And we want to make sure that it works. It's so, so important because they're life safety doors. And so best-in-class manufacturers will be able to provide the specs, the tolerances, and training if needed to make sure that these doors are properly aligned and fully operational. And so in summary, we want to provide safety in every building every time. And so you should expect more from a product that's providing life safety applications. And preventing the migration of smoke and fire in a building is imperative. And we have the source and ability to be able to do that. So perfect. Thank you. That does conclude the AIA portion of this presentation.
Awesome. Thank you so much, Candace. That was amazing and really informative. I learned so much. It will be great now. We've got a few minutes left, so I'm going to start the Q&A. If you have any questions for Candace, feel free to submit them. You can also raise your hand and I'll unmute you if you'd like to ask it out loud.
While you guys are putting those in, I'll just go through a question I've got previously that I thought was quite interesting. Somebody had asked me, why is a fire smoke door typically rated for 3/4 of the surrounding wall? And I think sometimes I get so blinded, I'm like, it just is. And so we looked into it, and it's typically rated for 3/4 of the surrounding wall because the walls are going to have things like garbage cans, shelves, picture frames, whatever it may be on it, whereas a swing door itself shouldn't have anything in front of it, and that's why it's typically rated for 3/4.
Oh, great. It looks like we've got one from Ken. The Mac is wondering the maximum door height and width for integrated door systems.
Sure. So your maximum door height and width is going to be dependent on your label, and so like for an A label, your max height is going to be 8 foot. And you can get 8'4" and like 3/16 inches max width, which will give you a clear 8-foot opening. But then as you go down in your labels, B and C max height will be 9, 20-minute and non-label would be 10. That's speaking specifically to total door. Other integrated door systems may be slightly different, but they'll be pretty similar. When you get over a certain like width especially, you're going to lose that nice reveal that you have to be able to maintain those tolerances. It's pretty difficult, especially with your IBC code and oversized door labeling to go beyond.
Great. All right. Any other questions from the attendees, or you guys good? Okay, cool. I am going to go ahead, and if anybody thinks of anything, raise your hand, I'll unmute you, but I'm going to go ahead and put up this poll once more. If you missed our little demo about Acelab in the beginning, or if you'd like to connect with us to learn more, you can just answer yes to this poll, and someone from our team will reach out to schedule a free demo with you. So there we go. All right, so I'll leave that up for a few moments. And then one other thing, if anyone out there is looking for more credits, we've got another event next week where credits will be available on the 20th. So you'll get a notification about that through email. And yeah, we hope to see some more of you there.
Thank you, everybody, for the opportunity.
Yeah, thank you, everyone, so much. And I'll just go ahead and leave this up while people trickle out. And one more reminder about that post-event survey. To get your credits, please give us your AIA number through that survey. And if you have any questions that you'd like to just reach out to me directly, my email is bo@acelabusa.com. Yeah,